The topic for today is equilibrium constant. Equilibrium constant is based on the law of mass action. Equilibrium constant. The law of mass action states that at constant temperature, the rate of reaction is proportional to the active mass. Active mass is the concentration of the substance raised to the appropriate power, which corresponds to the numerical coefficient of that substance in the equation of reaction. Let coefficient M, reactant A, plus coefficient N, reactant B, R, product. R is proportional to the concentration of A raised to power M, and R is also proportional to the concentration of B raised to power N. R is proportional to the concentration of A raised to power M multiplied by the concentration of B raised to power N. That is, R is proportional to A raised to power M multiplied by B raised to power N. R is equals to K multiplied by concentration of A raised to power M multiplied by concentration of B raised to power N, where K is a constant. For coefficient M, reactant A, plus coefficient N, reactant B, going into product C, coefficient P, plus coefficient Q, product D. R1, which is rate 1, is equals to K1 multiplied by concentration of A raised to power M multiplied by concentration of B raised to power N. Rate 2 will be equals to K2 multiplied by C raised to power P multiplied by concentration of D raised to power Q, where K1 and K2 are velocity constants of the forward and backward reactions represented at equilibrium. If R1 is equals to R2, then K1 multiplied by concentration of A raised to power M multiplied by concentration of B raised to power N will be equals to K2 multiplied by concentration of C raised to power P multiplied by concentration of D raised to power Q. Therefore, K1 over K2 will be equals to concentration of C raised to power P multiplied by concentration of D raised to power Q all over concentration of A raised to power M multiplied by concentration of B raised to power N is equals to capital K, where capital K is the equilibrium constant of the reaction at that temperature. K varies with temperature. Where K is the equilibrium constant of the reaction at that temperature, K varies with temperature. Examples. Number 1. N2O4 gas, reversible, going into 2NO2 gas, endothermic reaction. In the reaction above, an increase in temperature will A. Increase the value of the equilibrium constant, B. Decrease the value of equilibrium constant, C. Increase the reactant production, D. Shift the equilibrium to the left. The correct answer is option A. Increase in the value of the equilibrium constant. This is because the forward reaction is endothermic, and increase in temperature favors the forward reaction. Hence, increasing the value of the equilibrium constant. Option B cannot be the answer because the equilibrium constant value is being decreased. Option C cannot be the answer because increasing the reactant production is not true. Option D, shift the equilibrium constant to the left. No, equilibrium constant is shifted to the right. Number 2, 2H2 plus O2 going into 2H2O, delta H negative. What happens to the equilibrium constant of the reaction above if the temperature is increased? A, it is unaffected. B, it becomes 0. C, it decreases. And D, it increases. The correct answer is option D, it increases, because increasing temperature increases the equilibrium constant. Option C cannot be the answer because it increases, not decreases. It cannot be it becomes 0. And temperature affects equilibrium constant, so it cannot be option A. Number 3, N2O4 gas going to 2NO2 gas. In the reaction above, the equilibrium constant is A, concentration of NO2 over concentration of N2O4. B, concentration of 2NO2 over concentration of N2O4. C, concentration of N2O4 over concentration of NO2 raised to power 2. D, concentration of NO2 raised to power 2 over concentration of N2O4. The correct answer is option D, because equilibrium constant is the concentration of the products raised to their power coefficient divided by the concentration of the reactant raised to the power coefficient. Option C cannot be the correct answer because it didn't show that. Option B cannot be the correct answer because it did not raise the coefficient to the power. Option A can as well not be the right answer because of the same reason.